In this related rates problem, we have two ships, ship A and ship B, that start horizontally away from each other at noon. But then we want to figure out how fast the distance between them is changing at 3 p.m. Okay, what we're going to do is we're going to kind of superimpose a triangle here. We'll say that there's a vertical distance and a horizontal distance between the two ships. So let's draw a new triangle. The horizontal distance between the two ships, by the way, we're going to call x. The vertical distance we're going to call y. And the distance between the two ships we'll call z. The horizontal distance, we already know, is 80. That doesn't change. That horizontal distance will always be 80. They don't move horizontally, they only move vertically. So the horizontal distance, x, is always equal to 80. How about the vertical distance? We know that ship A is traveling south at 5 miles an hour and ship B is traveling north at 15 miles an hour. The question is, what happens at 3 p.m.? So 3 p.m. is our marker for when we need to figure out that vertical distance. Remember, they started here at noon. And 3 hours later, this ship will have traveled 3 times 15 miles an hour, or 45 miles. And this ship, ship A, will have traveled south 5 times 3, or 15 miles an hour, for a total of 60 miles. So we'll have y equals 60. And this is just because going north at 15 miles an hour for 3 hours, that'd be 3 times 15, or 45 miles. And again, ship A is going south at a speed of 5 for 3 hours, gives me 15 miles. So in total, a vertical distance of 60 miles has been put between the ships. And we're trying to figure out how fast is the distance between ship B and ship A changing at 3 p.m. So dz dt equals question mark. What we're going to do now is we're going to pick a formula that makes sense, that relate these values x, y, and z. Well, you probably know the Pythagorean theorem. X squared plus y squared equals z squared. Before we take the derivative of this, I'm going to point out that you can always plug in variables that you know are not changing. Now, y is changing because the ships are moving vertically. X is not changing because the ships aren't moving horizontally. That distance of 80 will be the same at noon, as at 1 p.m., as at 2 p.m., as at 3 p.m., as at 4 p.m. No matter what time, that horizontal distance will always be 80. So I'm going to go ahead and plug in 80 for x. So we have 80 squared. In fact, you know what? 80 squared is just, let's call that what it really is. 80 squared is 6,400. Okay. Now we have this equation. I'm going to take the derivative of both sides. The derivative of 6,400 is 0. The derivative of y squared is 2y dy dt. And the derivative of z squared is 2z dz dt. All right. What do we know? Do we know y? Yeah, we know y is 60. That's given to us. Do we know dy dt? It's not exactly given, or at least not in this chart here, but we know we can figure that out because ship B is traveling north at 15, ship A is traveling south at 5. So every hour, every tick of the clock, the ships get 20 miles away from each other. So that vertical distance is changing at a speed of 20 miles per hour because B is traveling north at 15 and A is traveling south at 5. So for every hour that goes by, 20 more miles are being put between the two ships. Okay, equals 2 times z, which we don't know yet, but we're going to need, times dz dt. Now, of course, we don't know dz dt because, after all, that's the thing we're trying to find. So don't be surprised if you don't know this yet. We're going to solve for this guy in a minute. What is z, though? Remember that we're going to probably have to reference the original problem, or the original triangle, without having taken the derivative, to see what the sides of this right triangle are. We know x is 80, y is 60, and if you do some quick Pythagorean theorem math, you take 60 squared plus 80 squared. Let's do this. 60 squared is 3,600. 80 squared is 6,400. Adding those together will give you 10,000, the square root of which is 100. Now you might think, wow, Andy, you're really good with squaring numbers. Yeah, but I just kind of use a trick. 60 and 80 are both have factors of 20 in them, so I'm going to scale this down by a factor of 20. Dividing 80 by 20 gives me 4. Dividing 60 by 20 gives me 3. And you might know your special 3, 4, 5 right triangle. So knowing this right triangle allows me to scale this back up to where I have 60, 80, 100. Okay, now that I know that z is 100, I can plug that in here. I'm going to say 2 times 60 is 120 times 20 equals 2 times 100 times dz dt. I'm going to say, let's just do this. 20 times 120 would be 2,400. 2 times 100 would be 200 dz dt. And therefore, I'm just divide both sides by 200 to get dz dt, which tells me dz dt equals 12.